All right, ladies and gentlemen, for our next set of notes, we're going to do something a little bit different today. Instead of writing directly into our notebook, we're actually going to be writing on this template. Now, attached to the Google Classroom with your notes is a copy of this paper. Please print it out and fill it out. If for some reason you cannot print it out, that's okay. As best you can, please copy these shapes onto a blank piece of paper, or go ahead and you can do it in your notes, but I think it's easier on white paper. We are going to create a quadrilateral hierarchy. Basically, we are going to classify quadrilaterals, a lot of the things we've been talking about, but I'm going to show you how we can break these into groups. Think of this like a flow chart. You're going to follow along from one step to the next. You're going to ask yourself some questions. Does the shape I'm looking at have these certain attributes, these properties? And if so, you'll continue down. Let me show you what I mean. We'll start at the top with quadrilateral. We've talked about this a lot. We talked about how quad means four. A quadrilateral is a polygon with four sides. A quadrilateral is a polygon with four sides. So all the shapes we're dealing with have four sides. They should all have four sides. The end. Now, you've got a couple questions that you're going to ask. The very first thing you're going to look at whenever you get a new quadrilateral, you're going to say, how many parallel sides does it have? How many pairs of parallels? Now, if it has 0 parallel sides, I'm going to turn this around. 0 parallel sides. So none of the sides are parallel. None of the sides are parallel. Then you're going to travel down here because you have a kite. A kite. Which a lot of you are going to look at and say, yeah, it's an upside down kite. Well, yeah, that's why we call them that. 0 parallel sides. A quadrilateral with 0 parallel sides is a kite. Now, everything below this box has these qualities, has this attribute, has 4 sides. The kite has 4 sides. 1, 2, 3, 4. Just like everything else on this paper. The difference is that there are no parallel sides. Now, there are a couple of other interesting things about a kite. There are some other attributes we get with a kite. Okay. First of all, both pairs of consecutive, we've talked about that, consecutive, next to each other, touching, both pairs of consecutive sides are congruent. Both pairs of consecutive sides are congruent. What that means, this long side right here and its consecutive side right here are congruent. And that's how we can show that. We draw these little lines. Now, actually, I drew 2. The reason for that, probably should have started down here with 1. I'm sorry. This is congruent to this. This line in geometry shows that these two are congruent. I do 2 lines for these because they are congruent to each other, but obviously they're not the same as this. So that's why this gets 2 lines. Again, I kind of did that out of order. Sorry about that, folks. Okay. You'll see a little bit more. We'll talk about some more congruence later. Okay. Now, both pairs of consecutive sides are congruent, so right there and right there. However, opposite sides. So say this side is opposite to this one. Opposite sides are not. They are not congruent. Now, this particular kite, I think just by looking at it, you can see that pretty clearly, but it should be true of all kites. Okay. All right, so if I've got a quadrilateral with no parallel sides, it's a kite. And we haven't really talked about those too much. Okay. But let's say that instead of 0 parallel sides, we have 1 pair. 1 pair. one, excuse me, one pair of parallel sides. Now, hopefully you already know, if your quadrilateral has one pair of parallel sides, then it has a special name. It is a trapezoid. Trapezoid. Okay. And we've talked about some of the attributes of trapezoids already. We've discussed a few of these things already. Okay. The first one is the most obvious. That's what's up there already. There's only one pair of parallel sides. There's only one pair of parallel sides. But we've talked about some other things as well. Okay. We talked about how there's at least one acute and one obtuse angle. Now I put at least because usually there's more. We've got, here's an acute, there's obtuse, there's obtuse. At least one acute and one obtuse angle. Normally there's two of each, but at least one. Okay, we can have some right angles too. We looked at some right trapezoids. Okay. Exactly one pair of parallel sides, four sides total, at least one acute and one obtuse angle. Now we also talked about how the angles add up. Consecutive angles should add up to 180. Let's include that as well. Okay. Now we do want to be careful with that because this is consecutive to that, but those don't add up to 180. It's just these ones that are on this different parallels. Okay. Consecutive angles add up to 180 if different parallels. I know we're kind of running out of space to write all that. Now don't worry, we're not going to write it all again, because the idea with this chart is that everything up above kind of travels down the arrows and is true of whatever it's pointing to. So a polygon with four sides that has one pair of parallel sides, that has at least one acute and one obtuse angle, and has consecutive angles that add up to 180 degrees on different parallels. If all of those things are true, you've got a trapezoid. Now, if all of those things are true, and one other thing, all of those things are true, so all the properties of a trapezoid and excuse me, non-parallel sides are congruent. So everything up here and non-parallel sides are congruent. So non-parallel. This is a parallel, and this is a parallel. And really, let's make sure we mark that on this one too. The non-parallel sides, call those the legs. If the legs are congruent, if they are the same, if they are equal to each other, then this is called an isosceles trapezoid. In fourth grade, you probably learned about isosceles triangles. You talked about triangles where the sides are the same. Isosceles trapezoid is very much the same. The legs are congruent. Parallel sides obviously can't be. If they're congruent, we have a different kind of shape. But if the legs are congruent, this one they're not. But down here, if they are, then you're looking at an isosceles trapezoid. Whew, all right. So, kites, pretty straightforward, zero parallel sides. Trapezoids is a little more going on, but really emphasize that there's one pair of parallel sides. Now, when we start getting to two pairs two pairs of parallel sides, that's when it starts getting interesting. Because here we've got a lot more options. Okay? When you have two pairs of parallel sides, you have more options. Now I think, again, based on what we've talked about in class, I'm hoping most of you can already tell me what this is. Both pairs of opposite sides, are parallel. Okay. So this side is opposite this side, and they are parallel. This side is opposite this side, and they are parallel. Now, opposite sides aren't just parallel. Opposite sides are congruent with each other. Opposite sides are congruent. So, if it's a polygon with four sides, if it has two pairs of parallel sides, kind of included that again, I know, and opposite sides are congruent with each other, we are dealing with a parallelogram. And again, parallels in the name. That should tell you just how important all those parallel lines are. Okay. Now, a parallelogram is still a quadrilateral. There are other quadrilaterals that are other things. But every parallelogram, everything down below, is going to also be a quadrilateral. Everything down under here will also be a parallelogram. Okay. This first parallelogram has all the properties of a parallelogram. Parallelogram, yeesh, it's hard to say so many times. All the properties of a parallelogram. But there is one difference. There is one big difference. Okay? It's got those parallel sides. It's got these parallel sides. Opposite sides are congruent. This is the same as that. This is the same as that. The big difference is it has four right angles. So everything from up above plus four right angles. So this parallelogram, this quadrilateral, is also a rectangle. Also a rectangle. So all the properties of the parallelogram plus four right angles. It's kind of if you take this and just straighten it out a little bit. Now, instead of adding right angles, let's say I take a parallelogram. So it's a parallelogram, that means it has all the properties. All the properties of a parallelogram. But this time, in addition to having two pairs of parallels, in addition to having opposite sides congruent, all sides are congruent. That means not only are opposite sides congruent to each other, they're congruent to everything. So this is exactly the same as this, exactly the same as this, exactly the same as that. They are all identical. This type of parallelogram is a rhombus. Okay, we're almost there. The last one is, ironically, probably the very first shape you learn after maybe circle and triangle. But it's a very complicated shape because it includes everything from quadrilateral down to parallelogram, down to rectangle, down to rhombus. It's like these two merge together to make a super shape. That super shape, of course, I'm not even going to pretend you don't know what this one's called. This one is our square. It has all the properties of dot, 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 all the properties of a parallelogram. It is a parallelogram. It has all the properties of a rectangle, because it is a rectangle. And it has all the properties of a rhombus, because it is a rhombus. The square gets to be everything. Properties of a parallelogram? Check. We've got our parallel sides. They are congruent to each other. Rectangle asks for 4 right angles. We got those. Okay. Rhombus says that every side must be congruent to each other. Yep, they're all exactly the same. A square is everything else. A square is everything else. Now, I can't quite get the entire thing on the whole page or on the screen at the same time, but when you go up from the bottom, if you have a square, that means your square is also this, it's also this, it's also this, and it's also this. A kite is also this. An isosceles trapezoid is also a trapezoid, is also a quadrilateral. We saw some questions like this in class. We said, is a quadrilateral also a parallelogram? Well, sometimes. It can be other things as well. Is a parallelogram always a rhombus? Not always. Sometimes it is. But here's an example of where it's not. Is an isosceles trapezoid always a trapezoid? Yeah. Yes, it is. Is a trapezoid always isosceles? No. That kind of thinking going back and forth can be a little tricky. Focus on these attributes. Focus on these attributes, these properties, and think about how when you get a new shape, you look at it and you're just checking one at a time. Does it have 4 sides? Quadrilateral. How many parallels does it have? No pairs? 1 pair? 2 pairs? Follow the line. Every step, just ask, does it have these properties? If it does, then it's this shape. Check and see if it's something else too. All right, we'll practice more of that in class, but for right now, again, please download the template. Fill out the template. I'm going to try to lift this up a little so I can get it on the screen. There we go. Fill out the template. Fill out the template. If you need to draw it on a piece of paper, that's fine too. But you should have this information. We're going to be referring back to it as we continue more activities in class. All right, thanks, ladies and gentlemen. We'll end here. I will see you next time.